Yesterday I told you at the beginning of the hour, today I would give you time to finish up that page and to turn it in, but then I thought about it, and I guess I'd rather teach first, and with the time we have at the end of the hour, you can work on this work and previous work, turn in whatever you want. So, yeah, pencils in the back. We have our new roller, so it should be working pristine, like every number is in there. Downside is I haven't renumbered the desks yet, so some desks don't even have a number.
There's some clear white.
Oh, did you put the clear white ones in? Those are spares for you to write a number on when you lose one. Well, we'll take out the clear ones when we get them. Yeah, so we'll just kind of work on that. Okay. Keegan, who do we got?
We got 42. We don't got it.
Did you say 42? Oh, you didn't stop at 36. Okay.
We could flip it upside down, 24.
No, that would be cruel to 24. Put the numbers that are above 36 and the blank ones in that little tray, and then I can take them out. Yeah.
What page are you?
Oh, that's a good point. We're on page 8.
Rule 17. Oh.
Perfect. First person of the day. Easiest question. What did we do yesterday?
We just did a bunch of graphing,
Of?
points and slopes.
That's not what we graphed. That's how we made them, but
Like,
what is that thing called?
lines.
A line, yes. Oh, nice, thanks. Nathan. So we graphed lines yesterday. And I kind of told you ahead of time what the purpose was. It was just to review how to graph lines, because the equations can come a bunch of ways. You can have slope-intercept, you can have standard form, you can have vertical, you can have horizontal. And on that piece of paper we wrote down on Monday, yes, that was Monday. On Monday, that has the ways that you can write those equations if you forget. Okay, what we're going to be getting to is talking about solutions of lines. Number one, y equals 2x minus 5. I can either have somebody come up and graph it, or they can just tell me how to graph it.
It was 14.
14. I have no idea where numbers are anymore. Some people don't want to claim their number. Ready? See, we'd work it out. I know there's 14 in here, but if they just don't want to answer that bad, we'll just. Do you remember how to graph 2x minus 5? I kind of heard you already whisper part of it.
So -5
Go-
on the y.
Go down 5 to start with, the y intercept.
And then 2 over 1.
Perfect. Go from here, we go up 2 to the right 1.
And then you can keep it.
And then just make a line? Perfect. Now, if you guys can't see, a lot of times what people did in the past was just look at the monitor. Okay. I am horrible at drawing lines up here. Oh, that actually wasn't bad. I can live with that. Okay, done. Tegan. Oh, I guess we did B.
10.
10? 10. I'm gonna ask you a different question before we get to C. Okay? Is the point 3,1 a solution? And we can write that in there if that's helpful for you guys. Is 3,1 a solution to this line? Or this equation? And I can give you some guidance if you want it. I just thought I would.
No.
Okay, where's 3,1?
3, 1 is over
Backwards, that's right,
Over
okay.
three, up one.
Okay, so 3-1 is right there. So is that going to be a solution to the line?
Yes,
Yes, how come?
because when you go over three, one, you get a point.
You're too much explanation. It's on the line. Okay? You know something is a solution if it's on the line, or technically what happens is you have a whole lot of dots in a row that make it look like a line. But 3-1 is one of them. Maybe not calling on somebody. Does anybody know a different way of checking if 3-1 is a solution if you don't have a picture? Yeah. So this is the x number, this is the y number, and if you have an equation like 2x minus 5, you can put those two numbers in and then find out if it's true. So I'll put 1 in place of y, 3 in place of x, and then we'll find out if the two sides are the same. So 6 minus 5 would be 1, and since both sides are the same, that would make it a solution. So you don't necessarily have to look at a picture to know if something's a solution. You can just check the numbers if you have an equation. So then that leads us to C. I realize most of you don't have a calculator on you, which is kind of why I changed the point that was C. I was hoping the next person could tell me how I would check if this is a solution. Without a calculator, I mean like.
36.
So, that would be Lexi, cause think 34 was the last desk number, so then that would have been 35, 36. Addie, you look occupied. Are you studying the notes on there? Yes, okay. Should I go to somebody else? I'll just ask that right now. Okay, do you think you could help her out?
Yeah, it's not a solution,
Oh, how would you find out then?
because the line will never be negative. It's going this way, so how would it ever go that way?
Oh, I got you. So you know how, what the heck, okay? When most people draw their lines, they draw that arrowhead at the end. That would just signify that it goes forever that direction. So it technically goes past the graph. It will go in the negatives. I have no idea if that was correct.
Okay,
But it does go into the negatives.
then I don't know.
No, that's fine. Does anybody know how we would check that point? Literally how Ava told me to do that point? Plug it into the equation. Now, you would need a calculator because those numbers are kind of crazy large. Well, teens aren't really crazy large, but we'll pretend. So you would plug -17 and -39 in to see if it would work. Now, so we've got -39 equal to 2 times -17 minus 5. I'll just tell you that 2 times -17 is -34. -34 minus 5 is -39. So, like, those numbers were big enough that it's definitely not something you would know the answer to just by looking at it. And our picture isn't big enough to go way down to -17, -39. So we definitely want more than one method of finding answers or finding out if something is a solution. But this one is. So we would say yes. Yeah, okay, I was gonna say, you guys have that line graphed, I believe, right? Okay? Why don't you guys graph y equals -1/2 x? That's the equation for number 2. See if you remember how to do it on your own. Put it on the same picture. Put it on the same picture as the other line. If you got more than one color, do more than one color, but most people won't. Most people will just label their line. So like, I'll say 2x minus 5 right on it, so we know which one it is. Now, what's difficult for me is we have to use this graph for the whole page, but it's hard for me to scroll.
Twenty-one.
Maybe over here somewhere? Leah, are you 21? Bridget? My guess is you're supposed to be 21 because that's 22. And I think somebody ripped it off. Do you remember how to graph -1/2 x? I can give you some assistance if you wanted.
Like, go down one, over two.
Okay, good. Where do we start from? But you told me the slope correct.
The,
Yep. So if there's no regular number, it's telling you to start in the center, and then you would go down one to the right two. And then you could do that repeatedly if you don't trust yourself to draw a line like me. Like that. However, I can cheat slightly. There we go. Now, if you want to write down the answer to A, go ahead. Basically, all the points that we just drew are points that are on the line, and those would be super easy to list. 0, 0, 2, -1, 4, -2, like, it would be easy to list those. So then we get to the question of the whole reason we're doing this topic. Does anybody feel like they know what I'm gonna even ask next? Mason does not? What's it say at the top of your page?
Not solutions.
What? It does not say that at the top of the page. Doesn't it say intro to systems of equations?
Well, that's it.
Well, isn't that the top of the page?
I mean, it's top left. I thought you meant like.
Gotcha. I'll be more descriptive next time. Okay, it says intro to systems of equations. A system of equation means more than one equation. Does anybody feel like they know what I'm gonna ask the question of? Like, what are we literally trying to do when we do these problems? When we graph two lines at one time? So far, we were finding solutions.
Find a single point that two lines connect.
We're gonna try to see if there are any points that are solutions to both lines at the same time. So, sometimes they will call those a solution to the system. Like, that's kind of the short way of saying it, but like, I'll do my best to try to phrase it correctly. Because each line has a bunch of solutions, like each line has a bunch of points. On this one, we can see that the two lines cross at one spot. Where they cross at one spot is a solution to both lines. So it's going to be a solution to the system of equations. So the point 2, 1, 2, -1 is a solution to the system of equations. I know, that does not really fit very nicely. I don't really like notes that are super organized. I like notes that are organized and grouped together by topic. Okay, so this is definitely what we're gonna be doing for the next couple days for sure. Is it's finding answers for two lines at the same time. Next page. Okay, now, we don't necessarily have to have a picture to figure these out. Like question number 1 is asking us, is it a solution to both of these lines? And we don't have a picture, so Tegan, who's gonna tell me how to do that one? And you guys can start doing it on your own if you want, like, I bet you know how to do it.
3.
3. Over there somewhere. Is that Gigi? Hey, is it? You're just not acknowledging it? I can't see you.
Yeah.
Okay, because words work too, yes. You remember how we checked if something was a solution on the last page when we didn't look at the picture?
The y equals x minus the y intercept.
I don't know, maybe I'm misunderstanding you. So like each point is an x and a y. We're gonna take those two numbers and put them into the equation to see if it works, which just means if it equals itself. So we're gonna try that in both lines. So if you guys wanna try that on your own, certainly do that. I'll write it up here. Put those two numbers into both equations and see if it works in both. So -4. Yes, 2/3. There's definitely gonna be fractions because of slopes. So you are welcome to use your calculator. Two-thirds times 6 will be 4. That one is -4 equals -4. This one, it checks. It works. Actually, instead of writing check, I should write yes. Okay, now I'm going to try it in the second equation. 6 -4. 6 minus 2 times -4. Yeah. And then I've got 6 plus 8. Does that equal 7? And then the answer is definitely no. Unless I did it wrong. Yes?
What are we trying to get?
We're trying to check if this single pair of numbers works in both equations. And so if numbers work, the two sides would equal each other. Like this one says -4 equals -4. The other one said 14 equals 7, which isn't true. So basically, if the two sides equal each other, it works. If the two sides don't, it doesn't work. It means the two numbers aren't a fit for that equation. Oh, I guess that one's not perfect either, no.
9.
I don't know where 9 is. That's 11. Oh, Aiden, what would I answer the question being asked? It says, the system means these two equations. It says, is this one point a solution to the system, which means, is it a solution to both? So you'd say no. Basically, the only way you can answer yes is if it's yes for both. The questions are going to be very easy. It's just knowing what to do. You can tell I'm going to lose my voice today. I wanted to be done by 9 so you guys had time to work on the various things, because I know not everybody's... Actually, I think this class had quite a bit of time to work yesterday, didn't they? No? Okay. Except, I guess Charlie did not. Yeah, we'll just pretend it was one person. I know not everybody did for sure, so I knew some people needed time. I feel like a half hour would be enough for you to be able to work on these and yesterday's. Okay, so we'll finish by 9. Tegan, let's finish up this last problem, which somehow the graph got moved to cut in the middle of the sentences. Yes, it's great formatting.
Are there any 40 numbers?
No, anything above 36 can be taken out. There's only 36 desks.
1.
It says line Q is shown in the coordinate plane. This is where it's super annoying. Sketch a line M so that the solution to the system of equations of lines Q and M is -2, 8. What is it asking us to do? Yep, we are trying to draw a line M, and then what, we have to draw a line M so that only one thing happens. Perfect. We want to draw M so that it crosses at -2, 8. That's the only thing it says. So we can do that. -2, 8 is right there. Line M, doesn't matter how you draw it as long as it crosses through that one point. Sure. What was this one? Q. Okay, done. Nice job. Five?
Yeah, fine.
Okay, says sketch a line Z so that the system of equations Q and Z have no answers. Okay, so Q is this one that was pre-drawn. How would I draw another line so that they never touch? Because that's what solutions mean. Perfect, perfect. If you draw a parallel line, I'll pretend I can draw a parallel line. Why is it in red? What's going on? My smartboard is going weird yesterday and today. Come on. You know what? I'm gonna cheat. Done. Pretend I did not cheat. What is this one called? Z. Hey, you can draw it anywhere you want as long as it's parallel to that first black line. Because if it's parallel, they'll never touch and they'll never share answers. -2, 8 is a point. So if it's gonna be rise over run, they'll make sure that it says equals M, or it'll be in an equation, but it will definitely be written as a fraction. How are we feeling on this so far? Now, I don't remember, but I believe it's at the bottom. What would happen if you graph two separate equations and they are on top of each other? How many common answers would they have?
Most.
All of them, which we would just say is an infinite number of common solutions. So if you graph two lines and they are on top of each other, which can definitely happen, they can have different numbers but be in the same spot. Then they would have an infinite number of answers. So those are the three things that can happen, which I know was written somewhere, but I think it's on a future page. You've looked at all the future pages? I've been writing the answer key to this packet for the last 3 days. I'm only on page, I don't know, like 35 or something. We're gonna be doing this packet for a while. I'm just trying to give you a little head start on that. If they cross once, there's one common solution. If they never cross parallel, then there are no common solutions. And if they are on top of each other, they have a lot of common solutions, so an infinite number. Okay, here's what I would like you, oh shoot. Here's what I would like you guys to try. So this page, and this does not need to be done today. But it seemed like you guys were really quick at graphing yesterday. But it doesn't need to be done today. This particular page has you do graphing. So page 11. The next page I think has non-graphing. Where's the equations? Must be the page after that. You know what? Never mind. I guess it doesn't have the page. I wonder if that got cut out on accident. Oh well. So I guess we're just doing page 11 only for now. I wanted to give you some that we're asking you to find out if they had common answers and it gave you both equations. But that's okay. We'll get plenty of chances to do all the various things. So let's just make page 11 the assignment. And then what I'll do is I'll shut off the smartboard, so anybody who wants to turn in their work from yesterday can. And do you guys want me to put page 11 in right away today, or do you want me to wait till tomorrow?
Tomorrow.
Okay, sounds good to me.
So we don't do this one?
That's what we did yesterday.
Yeah. Yeah, we know we're not.
Oh, if you need to finish page 4 and 5, do that first. And then get that turned in, or shown to me, and then page 11 is the assignment, but I won't even put that in the grade book yet.